In this video, we will continue proving the identities. Right now, different types of sums, different types of identities, wherein we have to use the logic and we have to make use of all the identities that we have learned. We have to make use of all the conversions and we have to think which one is correct and where to use these identities. Now, whatever you do on one side which you are solving, say for example here, you have to connect it with the right hand side also. That connection is very important, right? Now, for example, I have to prove that cosec A plus sin A into cosec A minus sin A is this. Now, at the first instant, I know now I have to convert everything into sine and cos. But if I look at this, isn't it A plus B into A minus B? Let me apply that first and then I can convert it into sine and cos. So A plus B into A minus B is cosec square A. This is my left hand side which I am solving. Cosec square A minus sine square A. Alright. Now, what do I want? I want cot square A and cos square A. Cosec square A, can it give me cot square A? Right? I know the identity that cosec square A minus cot square A is equal to 1. So, in place of cosec square A, can I write 1 plus cot square A? Yes? Okay. So, then in place of sine square A, can I write 1 minus cos square A? Right? Because that's what I want in the right hand side. So, 1 plus cot square A minus 1 minus minus becomes plus cos square A. So, 1 and 1 will go. I am left with cot square A plus cos square A. That's what I have to prove. This is my right hand side, right? So I have proved this identity. My left hand side is equal to right hand side, right? Although I have not written the left hand side first, you should always write that. Let's write that in this question. We have sec A plus cos A into sec A minus cos A. So this is my left hand side. Let me write it. So sec A plus cos A into sec A minus cos A. This is my left hand side and I have chose to solve the left hand side. So again, this is A plus B into A minus B. I can write this as A square minus B square. Now, let me have a look at my right hand side. I want sine square A and tan square A. Can I do anything here so that I can get this sec square A in terms of tan square A? Yes, I know that if I write 1 plus tan square A, it is equal to sec square A. And I don't want cos square A, I want sine square A. So I can write cos square A as 1 minus sine square A. Right? Now this will give me 1 plus tan square A minus 1 plus sine square A. So I get rid of this one. Finally, I am left with tan square A plus sine square A. Is it my right hand side? Yes. I have proved my left hand side equal to right hand side. Right? Okay. Now, another type of sum. Here, cosec A minus sin A into sec A minus cos A into tan A plus cot A. I have to prove that this is equal to 1. Now, I don't see any A plus B into A minus B's here. I don't see any squares here. So what should I do? I should simply convert everything into sine and cos. Let me do that. Cosec A. How can I? Okay, let me write first left hand side. Write this entire thing. I have cosec A minus sin A into sec A minus cos A into tan A plus cot A. Right? Okay, now let me start converting, or this will be 1 upon sine A and this will remain as sine A only. Here sec A can be written in terms of cos as 1 by cos A and this cos A as it is. Tan A can be written as sine A upon cos A plus cot A can be written as cos A upon sine A. Right? Okay. So after that, here I can take sine A as LCM. I'll get 1 minus sine A. Here I can take cos A as LCM. I will get 1 minus cos A. And here I can take cos A into sine A as LCM. So I am getting sine square A plus cos square A. Right? Then let me multiply all the numerators and all the denominators. So what will I get? Let me check. So here I am getting 1 minus sine A. Right? Oh, this will be sine square A. If I have taken this as LCM, this will be cos square A. Right? Into 1 minus cos square A. Into sine square A plus cos square A, we know is 1. So all the numerators we have multiplied together. Let's multiply all the denominators together. So we have sine A into cos A into cos A into sine A. Right? Now, how much is my 1 minus sine square A? I know this is cos square A. How much is my 1 minus cos square A? I know this is sine square A. Now let me check what I have in the denominator. Sine A into sine A is sine square A. And cos A into cos A is cos square A. So I can get rid of this and I got 1, which is my right hand side. So I have proved my left hand side equal to right hand side. Right? Oh, this one. Now, this is tan square A minus sine square A. You have to prove is equal to sine square A into tan square A. So what should we do? We can do it in any way. Like for example, let me first write the left hand side. What is my left hand side? Tan square A minus sine square A. You will tell me that we can do it by conversion also, because we know that tan square A is sec square A minus 1 and minus sine square A can be written as 1 minus cos square A. Right? So sec square A minus 1 plus cos square A. So isn't this sec square A plus cos square A minus 2? Now if we look at this closely, isn't it sec A minus cos A whole square? Because sec and cos are reciprocals of each other. So if you open this, you will get sec A, sec square A plus cos square A minus 2 sec A cos A. So sec A and cos A will get cancelled and you will be left with only 2. Fine. Now, then how will this help me? Let us see. We can write this as 1 by cos A. Now we will convert. This can be written as cos A only whole square. Now here if I take cos A LCM, I'll get 1 minus cos square A. Right? And then this whole square. So finally this will be 1 minus cos square A is sine square A. Right? Upon cos A whole square. Okay? I have to get sine square A into tan square A. So if I open this square, what will I get? I will get sine 4A upon cos square A. Now can I write this sine 4A as sine square A into sine square A upon cos square A, right? Now how will this help me? What I will do is, can I write this as sin square A by cos square A? This I have written under this, into sin square A, right? So if there would have been plus or minus in between, then this cos square A would have gone under this sin square A also. But this is multiplication. You can put it under sin square A or under this sin square A, right? So what is my sin square A by cos square A? Is it tan square A? Yes. And this can be written as sin square A. So that is your right hand side. Now, is there any other method of solving this? Yes, there can be. You can simply convert it into sine and cos. Let's try that method also. What you can do is, you convert this into sine and cos. This will become sine square A. Convert this into sine and cos. Sine square A by cos square A. Then minus sine square A. Right? Now you can take cos square A as LCM. So what will you get here? Sine square A minus sine square A into cos square A. Now you can take sine square A as common. What will you get inside? 1 minus cos square A. And then cos square A you have in the denominator. So sine square A, 1 minus cos square A is sine square A upon cos square A. Now you have reached this stage. You can write this sine square A upon cos square A. You can put this cos square A under 1 sine square A into sine square A. So that will give you tan square A into sine square. So anything that you are converting into sine and cos will give you the same results, whether you are using the identities directly or converting this into sine and cos, right? Okay.